What's up, hackers? Welcome to TTI Live. My name is Taggart, and tonight we have a little bit of malware analysis for you. A little bit more of what we were doing last week, maybe? Week before? Yeah, week before, because the holidays. But, yeah, so we have a new sample for you, and this one is a little bit different than the one we saw before, which was from the Bootloader malware family. This one is from the FakeUpdates, or otherwise known as SocGholish or SocGholish. I'm not really sure how you're supposed to pronounce it. I think you're not supposed to be able to pronounce it, really, is the truth. But from that malware family. So depending on your threat intelligence source, it'll be called something different, right? So up here I have Red Canary and Proofpoint intel reports from those respective intel sources, and they're calling it SocGholish. I don't know why, but Mandiant continues to refer to it as FakeUpdates. So that's kind of how, since I work with Mandiant, that tends to be, not work with Mandiant, that tends to be what I refer to it as. But Gholish is a reference to the Gola from Dune, if you say so. But kind of interesting to understand what it is doing. And right here is kind of the kicker. So SocGholish is primarily known for its drive-by download of initial infection. By the way, how sweet is this tiling browser? Thank you very much, Vivaldi, for this feature, that we can do a comparative analysis easily of these two things without having to tile two different browser windows. So this staging here is, I think, really important to understand. But this isn't the way that it always goes. Okay, this is one of the common attack paths, but I have seen others. Let me drop that down. My mic is like really spiky tonight, and I don't know why. I think I need new audio cables. Okay, so what we have here is an email as the start. Phishing, of course. But what do? It's not like it's an attachment, really. So what happens is you click on a URL and you visit a specific website. Now, this website, if you just visit it, this is the trick. The website, as you visit it, will not look malicious or provide a malicious drive-by download. It is only by the link provided in the email that this thing happens. Usually what has occurred is that the website that's been compromised is a WordPress site or something like that. There's some PHP in the back end. What that means is that you won't even be able to see any like malicious JavaScript that creates the thing unless you visit it the right way. Okay? So it really confounds that first part of analysis, trying to figure out how did this thing get there, right? Because when you do the incident response, you'll see users visiting a specific URL or clicking on an email. You'll see all that. But if you're not aware that that URL from the email is the thing that as it's formatted and coming from the right spot, like all of that has to be in the right place in order for the malicious component of the site to trigger. Okay, so once that happens, the next stage really depends on the variant of the malware. But what I've been seeing a lot of recently is what comes next is malicious JScript, a .js file. So that's going to be a zip folder. And again, this is one of those things where users really need some more education here. We have done an okay job, I think, about educating most users about malicious Office documents, right? Or like, don't click on .exes because that's not the thing you're looking for. Or you would hope so, right? Certainly, folks my age are aware, having, downloaded from LimeWire, like Stadium Arcadium.exe or whatever, and realizing that that wasn't the song that we were looking for 40 minutes. We're aware of those sorts of attacks, but we're probably less aware, and I think everybody is less aware of other kinds of files. So we know, of course, that .iso files were a real problem, especially over the summer. For me, this is in the same vein. Windows has a way of using JavaScript as a sort of script host language natively. So a .js file will be executable. But most folks don't know what a JS file is, right? So they'll look at it and say, is this the thing that I'm looking for? Or for some reason, this site gave it to me. It must be something that I want. For whatever reason, that flow bypasses common vigilance. Okay, so the JScript is invoked. Then what happens next? That's kind of where we're going to focus here tonight. Is not on that first payload, but on the second payload. It really depends on the variant here. So you might see some WMI calls. You might see different a second VBS script. You might see a number of different things. But what we're after now is what's going on here. What would be referred to as the C2 server. And if we're following this attack chain, this would be kind of the third payload. Hey, DZE64. Thanks so much for the raid. We're doing some malware analysis here tonight. Hope that's of interest to all of you. And I hope that your stream was good. All right. So I had a fresh sample of this malware come in, and I was playing with it a little bit yesterday. And it's pretty interesting. So the first thing to know is that I kind of can't believe that I got it the way that I got it, which was I was able to directly contact the second stage URL. What does that mean? I will show you. What that means is this is the URL in question, okay? This is what we found. sdvubjser.top, and the full URL is /f23.svg. So I have straight up downloaded this. This is the thing that the initial malicious JScript went and got, or tried to, I should say. The good news is that this URL was already in some block lists that we had, so our particular user was not impacted at all. We're fine. But I was curious. I wanted to know what else this thing could have done, so that's what we're going to take a look at tonight. Let's take a look at this thing, just real quick. This is going to be largely static analysis tonight. I do have the malware lab up and kind of ready to go in the event that we have cause to use it. At least I think I do. But I would rather not, if I can get away with it. Hey, Technique, good to see you. Okay, that's good. All right, let's take a look at this thing. Now, I want to be cool and use Vim, but the truth is, because of the nature of this, VS Code is probably going to be the better choice here. All right, so I'm looking at this. There's a gigantic chunk of base64 encoded something or other. And then as we move down, we see a bunch of PowerShell. So for that reason, we're going to fire this up in code. I'm just going to open the code. I'm just going to open code in this folder and make sure that we have everything we need here. So trust the authors. Okay, so this thing obviously isn't an SVG, So we're going to switch this up, and we'll just call it rename.ps1. Much better. And by the way, I have PowerShell installed. Okay? I actually have PowerShell here in my Kali machine. 726, there is newer, but that's going to work fine for us. And what that means is that I may be able to run a lot of this PowerShell stuff directly on my Kali machine without worrying about about anything else. OreoBite, right off the bat, has requested that I play a song. Well, I think we can do that. Thank you, OreoBite, and hope you're doing well. Hope the new year's treating you well. All right. Let's see. I'm gonna hold this one in reserve just in case there's another one tonight. Oh, you know what one I haven't done in a while? A Bo Burnham song. I think I haven't done that one in about a year. All right, this is a Bo Burnham song. Stunning 8K resolution meditation app. In honor of the revolution, it's half off at the Gap. Deadpool self-awareness, loving parents, harmless fun. The backlash to the thing that's just begun. There it is again, that funny feeling, that funny feeling. There it is again, that funny feeling, that funny feeling. The Surgeon General's pop-up shop, Robert Iger's face. Discount Etsy agitprop, the Bugles take on race. Female Colonel Sanders, easy answer, Civil War. The whole world at your fingertips, the ocean at your door. Live action Lion King, the Pepsi halftime show. 20,000 years of this, 7 more to go. Carpool karaoke, Steve Aoki, Logan Paul. A gift shop at the gun range, a mass shooting at the mall. There it is again, that funny feeling, that funny feeling. There it is again, that funny feeling, that funny feeling. Reading Pornhub's terms of service, going for a drive. Obeying all the traffic laws in Grand Theft Auto 5. Full agoraphobic, losing focus, cover blown. A book on getting better, hand delivered by a drone. A total disassociation, fully out your mind. Googling derealization, hating what you find.
that unapparent summer air in early fall, the quiet comprehending of the ending of it all. There it is again, that funny feeling, that funny feeling. There it is again, that funny feeling, that funny feeling. Hey, what can you say? We were overdue, but it'll be over soon. You wait. Hey, what can you say? We were overdue, but it'll be over soon. You wait. Ba-da-da, ba-da-da, ba-da-da-da-da. Hey, what can you say? We were overdue, but it'll be over soon. You wait.
Alrighty. Thank you very much. Thank you, Oreo. Alright. Now, where were we? We're looking at this redonkulous bit of PowerShell here. And I think what I'm going to do, just looking at this, is kind of excise this out. Right? Because this thing is obviously a bunch of base64 encoded whatever, and I don't really care about it at the moment. Like, I will care about it, but for the moment, I care about the rest of this. Right? Because look at how long this is, and then we have just the rest of it. Okay? So, I think what I'm going to do is take all of this, like the rest of this, and make this into a new thing, right? We'll save that as evil script 1. Okay. So let's just see what we're dealing with here. We have a bunch of really, like, lamely encoded stuff, right? It's like the variable names are encoded, but nothing else is, which is fine, right? Like, that's okay. We don't have to work that hard. So what are we dealing with here? So let's see. We have whatever this is. It's a system text encoding ASCII, so I think it's from our big payload, maybe. Whatever this is. We'll work on this. We'll see what this is. This whole function, right, begins and ends here. Oh, you know what I need to... Oh, no, the brackets are... the brackets are differentially colored. I do have that set. So let's see. I'll tell you what this is right here. Oh, here we go. So this is the encoded data, whatever this is. So we're going to go ahead and just change this up. Yeah, I don't know what anybody was talking about with that other way of doing this, but encoded payload. That's that. Okay, so encoded payload was that parameter that's coming into this function. And I suspect this is a decode, like a decode and decrypt payload situation. I suspect that's what this is. So we'll call our shot there. Decrypt payload. Okay. And it does sort of seem like we're working against that, right? That we had this gigantic encrypted payload, and then we're going to decrypt it. Okay. So this would appear to be the decoded payload. Not decrypted, but decoded, right? Because the thing is in base 64. So the first thing we need to do is base64 decode it. So I think that's what this variable is about. So we'll go ahead and rename that, call that decoded payload. And then I'm curious, just looking at this, does anybody have any guesses what this one is here? What this whatever.getBytes is? I believe this is just ASCII encoding. I think this is just saving this access. We're going to say ASCII encoding. Any guesses? What is this? What are we doing here? The Ivy, the initialization vector. I don't know if I'd called it the initialization vector. I would definitely call it the key. Yeah, it's the key. That's right, it's the decryption key. Because if you look very closely, enhance. Can I not zoom in anymore? There we go. Enhance. There's an XOR. There's a byte-based XOR in here. And yeah. So this is the key. This is just the decryption key. We're just going to call it key. Easy days. This is the thing. It's not like super complicated. At least this part isn't, right? All right. So let's see. And then we have, this is kind of interesting. I always think this is funny. What is happening here? I'm going to leave this one alone for a moment. And then down here, let's see what's going on here. First, we have a for loop. And then we have another for loop. And so the way that you do for loops in PowerShell is very similar to the way that you do for loops in JavaScript or C or C++. Okay? So you have a for keyword, and then you create a temporary variable called an iterator. You initialize it to a specific starting value. You set up the condition until which the loop will run, and then you set up the... and then you set up the... In theory, you would set up the incrementer, but it looks like they've left that off here, which you can do, but then you have to, manually do the incrementation, which is fine. You can do that. So an XOR like that usually indicates a decryption, which can usually lead to an encryption key. I don't know if I'd put it like that, Matchstick Boy. So basically what's going on, this isn't, tricky encryption, right? Basically what they're doing is they're preventing automated analysis, right? They're preventing whatever their payload is from being easily detected. Because, again, they're just giving us the decryption key. And as a matter of fact, unless they're doing something really funny in here, we can now, with this and understanding how they've done the encryption, what we can do is we can take that whole big chunk of base64 and we can toss that into CyberChef. That's the easiest way for me to do it. Toss that into CyberChef, give it do a two-step from base64 and then XOR with this key, and then just you're done. Right? Then that's the payload. So what it indicates is that they're trying to beat lazy EDR like Defender, right? Because they won't go to the trouble of trying to extract some key to find out whatever that giant payload was. Because how could you possibly automate that? But we can do it because we're human beings. So is this more obfuscation at this point? Yeah, that is correct. It's obfuscation and evasion. XOR is technically encryption, but the thing about XOR is that it's reversible, right? with either the key or the... XOR is funny because, let me get this right. If you have the ciphertext and the key, you can get the clear text. If you have the clear text and the ciphertext, you can get the key, right? So you only need two parts. It's not a one-way situation like a hash. Okay, so because this is a for loop, and because there are 2 of them, what I'm going to do is I'm going to just take this variable, this qtn25, and call that I, the standard for loop iterator variable, right? And then what is this? What is this thing? Well, at the moment, it's being saved as this decoded payload, but I believe this is where we're doing the encryption step, right? Because you can see it happen here as well. So I think we're going to call that the decrypted payload, which is what eventually gets returned, or some version thereof. Okay, so now or maybe it doesn't get decrypted. We'll find out. But for now, we're going to call it that. And then here, notice this 2C is turned into a memory stream. Oh, yeah. Okay, so there's another step here, which we'll get to. But, okay, so the decrypted payload, but then there's one extra layer. Okay, so this variable, yeah, okay, is what we load into the memory stream. But for now, we'll say for... Now, this is a second iterator. This is a second for loop. So what we're going to do is we're going to say, oh. Why do we need 2 loops? What's going on here? The first loop is going through each byte of the decrypted payload, or the payload that we've just decoded, right? And then for O equals 0, O is less than the key out. So the first loop is going through every byte of the payload. The second loop is for each byte of the payload, also iterate through bytes of the key. And what we're doing is we are decrypting each byte in turn of the payload, right? With each byte of the key. And the thing is that it's a cycle. So basically we're going through every byte of the key, right? And we're using each byte of the key in turn. And then when we get to the end of the key, we come right back to the top. That's what the second loop is doing, right? Because it says if I, which is our iterator, is greater than or equal to the decrypted payload dot length. So as long as when the I gets bigger than decrypted payload dot length, O is equal to the key dot length. O plus plus. And so that ends this inner loop, right? And then we move on to the next byte. Does that make sense? So it's like the key it's an iterative XOR. It's XORed for all of the bytes of the key, I think. And then we move on to the next byte of the payload and do the same thing. So it's like an annoying decryption. I wouldn't want to do it, but that's kind of how this is implemented. So with that in mind, then it's almost like they're shadowing this, or they're copying it over so that they don't mess with the original. So we're going to call that decoded payload copy, because that's what it is. And then this is indeed the decrypted payload. Hey, Husky. Good of you to join us. So now we have, once this is done, we have a new memory stream, which begins with our payload. So we can call this just straight up memory stream, I think. Actually, just kidding. We're going to call that payload stream. And then because we have this other memory stream, which we will call memory stream. And then we have one last thing, it looks like, one big thing, and this is really the other trick, which is that this payload appears to be 1, base64 encoded, 2, XORed with the key that we see there, 3, it's gzipped. So it's compressed, it's encrypted, or it's XORed, and then it's base64 encoded. So those are the things that we need to like deal with to get at it, right? So now decompress. So this is the decompressed payload. Hey, 8-bit supercomputer, thanks so much for joining us. All right, we're almost there. So our memory stream now has the decompressed payload. So now we're going to call this payload bytes. And then this thing is just like an extra variable. I don't even know why we're doing this, but this is the result. Okay. So we have we've taken apart this decrypt payload function that was lightly obfuscated, right? With just some funky variable names, but nothing else in here was obfuscated. But this is what we got, right? And don't forget, for those of you who just joined us, this came straight from the source. I pulled this from the bad guy's own domain. This was what their second stage payload was supposed to be. They just let me have it because they hadn't shut down this part of the infra yet. Which, fine by me. I just realized I left the camera running. Okay. Back to the code. So, very little left here. So, what do we have? We have an extra little baby payload, right? Which we can play with. So what, the PowerShell script has an SVG accession? So it's like this, 8-bit. So what you're not seeing is the first stage, which was a JScript file, a JavaScript file that Windows can execute, that was downloaded by a user. They clicked on it, and then that JScript file reached out to this URL. Okay? And I don't know why it's HTTP, but what they're doing is they're putting SVG on the end here, but it's PowerShell, right? And the thing is, you can pass whatever to invoke expression. PowerShell don't care, right? So what happens then is the PowerShell will execute. So why is it an SVG? They're basically just trying to get around filters that are looking for .ps1 at the end of a URL, right? It's not particularly sophisticated, but it is just one layer of OPSEC, which they were willing to do, as opposed to using TLS SSL, which for some reason they weren't willing to do. I guess TLS certificates are just too much trouble for SocGholish. Also known as fake updates. So, all right, now what's this all about? This decrypt payload, which we haven't seen. Oh, right, so this 4RGG12, that was the... Whoops. That was this guy up here, right? This gigantic thing that we pulled out. So we're just gonna call this wherever it is. A huge payload, right? And then we have this other payload that they're giving to us. What is it? Alt-Z? Yeah, there we go. For word wrap. And that's getting piped directly to invoke expression. All right, so let's start with this and see what this is. ASCII get string pipe to IEX. All right, so this should be pretty easy days. For this one, we'll go to CyberChef. So things we know about this. Time for Vim. Honestly, no, and I'll tell you why. While we can do the base 64 pretty easily in this, the G-zipping and stuff is going to be a pain. So CyberChef is, I think, the right tool for the job here. So step 1 is get it out of base 64. All right, that's part 1. Part 2 is we need to XOR it. And we know that we have the key, and in fact, this is a UTF-8 key. Right? It's not, we don't have the hex bytes. What we have is the ASCII key, right? So we're going to take this key, toss this in here. Okay. Now this is, I believe, unless it is hex. No. UTF-8 is right. I think we're good here. Now, if this doesn't work, yeah, Husky, I think I might do the right host for this one, because this looks a little bit wrong. I'm expecting to see stuff here that I'm not seeing. If we do G unzip, there we go. We were good. We were in good shape here. But take a look at this. Now we have this whole new thing. Which we can turn into EvilScript PS2. So I actually think that this was a little bit cleaner than doing write host. Because I had the whole step, the whole process down, right? 1, 2, 3, and then we get the output. And I can use the same process for the gigantic payload. Now that's larger, but I'm kind of letting, the reason I like that is because I'm letting the compute happen there rather than in one of my terminal shells. So now that we know that this works, we can go get the giant payload too. Let's do that as we examine. So let's go all the way down to the bottom of this beast. And I'm actually going to turn off the G-unzip for reasons which will become clear in a moment. Turn it back on. Okay. Let's see what kind of a thing this is. Oh, actually, I don't have to guess. If I click on the view slice... Hey, there it is. Magic Bytes, what's PK? That's a zip file, friends. Yep. So we're going to just go big payload.zip. Yeah, there are some like special zip files that also will have PK in there, but generally speaking, it's a zip file. So we're going to give it a shot as a zip file. Oh, yeah. And then we just got a whole bunch of new stuff in here. Look at that. That unzipped perfectly well, including this client32.exe. Okay, so hold that thought. We'll get there. But let's take a look first at our new evil script 2, right? We want to save this as evil script 2.ps1. And we have a little bit more deobfuscation to do here. The other thing I want to do, just because it's going to drive me crazy, is I want to format this document. Much better. Okay. Looks like we have a new key or something going on here. And even just the shape of this looks similar to what we saw before. Check this out, right? We have a nested for loop. We have the same sort of thing with like a dot length. And we have a bxor. So plainly we have another decrypt payload situation here. All right, so we'll call this decrypt payload here. And there's also this method. And the method is also kind of a keying mechanism, it looks like. I don't know why, but this method is just something that you have to pass to the function. So it's like you need to have both of these in order to execute this, right? To get this key, right? So actually, this is encoded payload, I believe. Or let's just call it payload, because that's, yeah, okay. And then here, this one does work a little bit differently. Just a little bit differently. Because we didn't see the get bytes before, I don't think. No, we didn't. We saw the get bytes for the key, but we didn't see it for the payload. So it is slightly different. Okay. It's, you know what it's like? This one looks a little cleaner. It's like they had somebody else write the first script, and then someone else improved it for the second one, and this one is the result of that refactoring. So it's a little bit slicker. It doesn't use as many intermediate variables, right? But they said, like, the first script is fine, it's working, let's not worry about it. But the second one reflects some improvements in method. It's so wild to get inside the mind of malware developers, right? To see how they do what they do. Okay, so here we'll just call this result because it plainly is. That's what we're returning. The junior SocGholish engineer developed the first part, you're saying? Yeah, I think. Or it was like Stack Overflow copy pasta or something, and then they, or ChatGPT, who knows? And then they improved it for the second one. Because this method, this implementation does the same thing, but it does reflect, I feel like, a refinement in just programming style. Awesome watching and learning for this level of analysis. Well, thank you very much. Please know that I'm learning along with you. I would never consider myself a malware analysis expert. Any suggested learning materials for this high-level analysis? Husky, you want to help them out? Yes, my friend and partner Husky has a course called Practical Malware Analysis and Triage, which will teach you how to do malware analysis, both at this level and lower. It is a fantastic course, and at even full price at $29.99 is a steal for the skills that you gain from it. And Husky has even recently added new updates to the course, even though it's over a year old. So definitely check out PMAT if you haven't. Do I still have a PMAT command? I don't. I'm sorry about that. I will have to get that going. But I know that Husky has the affiliate link ready to go. All right, so again, we're going to just rename these iterator variables nice and easily. We'll call that I, and then the internal one. I kind of go IO. That's just a pattern that I picked up when I have to do a nested loop. And then the Saguga here is the key. So we'll turn that into key. All right. Now, here's something kind of wild. The second function is not obfuscated at all. Like, not even a little bitty bit. So we can just read this and understand what it's doing. So the first one here, this is a little bit tricky. I know that HGB knows what this is, and I bet some other folks do as well. But the percent sign is a shorthand for what? HGB can't answer, and I think technique probably. Grimmy. I don't think Grimmy's here. If Grimmy were here, couldn't answer either. Yeah. But other folks, what is this percent sign? What is it doing? It's not modulo. Yeah. Well, Husky, you're automatically DQ'd. What is this percent sign? Somebody go ask ChatGPT. It probably will get that right. Yo, honestly, what was I using ChatGPT? Oh no, I think I came up with the best ChatGPT usage. You know what it was? JQ syntax queries. I am never, ever, ever looking at the JQ documentation again. I am just going to ask ChatGPT what I'm supposed to do to get the data that I want, and so far it's been very reliable. Yeah, actually, I was like, sorry, this is a total tangent, but I don't know if you've noticed, but for the last couple of weeks, my latest subscriber part of the Twitch stats at the bottom left has been broken. It kept on saying my name. And I didn't know why, so I finally decided to fix that. And I was like, I think I need to change up. I think Twitch changed their API in some weird way, and I need to change my JQ command that I'm using inside that script to make that work. And so I was like, I don't want to do this. Please don't make me. And so I basically just asked ChatGPT. I was like, hey, I have, this is the shape of my data. This is what I'm trying to get out of it. What is the JQ syntax that I need to use? And it got it in one. No problems at all. So that's cool. Okay, cool. Malware Lab is up, kind of. Where'd you all go? There we go. Pro tip to find out what things mean in PowerShell: get alias %. Get alias, I like. Yes, indeed. Well, well, well. It is an alias for each object, since no one was able to get there. So basically, yeah, for each is the other alias. I really wish that map were the alias, because that's what it is. This is one of the things, like, I really want to like PowerShell more because it is at its heart a functional programming language. And this demonstrates that concept. Where what we're doing here is we're taking a join of these three different byte sequences, right? From 0x30 to 0x39 to 41 to 5A and to 61 to 7A. What are we doing? Right? This is alphanumeric. Right? And we're just piping that to get random with a count of 12. And then what we're doing is, for each of that, we're getting the character result. So all we're doing is producing a random name using this method. And we can see it happen. Right? So this is our first, it's not really our first, but it's the first behavioral indicator that you will definitely see on disk. Okay? Independent of all this other stuff that it's dropping, which might change, but this right here, look at what's happening. It is writing make dirt. It's creating a folder at your app data location and then this random folder name. Okay? Now don't forget that app data is not app data local in Windows. Right? It's roaming. So make sure you're looking in the right directory if you're hunting for this. Okay? And as a matter of fact, I mean, roaming has a lot of weird stuff. But that being said, 12 characters of alphanumeric by itself, exactly 12, may not be a particularly high false positive rate for you. Are they doing this until they get randf to equal the method value, or is that a different length, something else? We're outside of the thing where the method was technique. That was for the decryption, and we're kind of done with that. This is just to create the persistence location. Yep. Okay. So it makes a random folder name inside of the app data roaming folder. And then client name is whost plus.exe. Whatever. Notice that it is removing everything in temp.ps1. Now, we know a little something about why temp is showing up here at random. We covered it last time we were doing malware analysis. I'm wondering if anybody remembers. We haven't seen temp show up anywhere in this so far, really. But if we think about the entire attack chain, where does the temp folder show up? And don't forget that it's not C Windows temp. It's the user's app data local. Where does that show up? So we did this last time when we were doing the bootloader payload. If you have a zipped file on Windows, right, and you double click on it, and then you go into its folder or you double click on any of the files that are inside without manually choosing to extract the zip, what Windows does is it, in the background, extracts it for you, but stores that extracted data at your temp directory. And so what this is doing is saying, let's assume that a user did what we expect them to do, which is just double click on the zip file and then click on the first stage payload, right? Let's assume that's what they did. All right, cool. Well, now I'm past that and I need to start cleaning up my tracks. So I'm going to remove all of the PS1 stuff that was left over from what I've done so far. Kind of interesting that it's .ps1, right? But we're going to clean that up. Okay. And then we have a .zip. And then we're going to write host. Oh, here we go. GNQJB. I believe this was our big payload. From an earlier script. And don't forget that all of this is running inside the same PowerShell session, right? So those variables will survive from one script to the next. All right, set content path, lit, value, big payload. So basically we have this payload in memory, right? Remember it was a memory stream? And we haven't written it to disk at all yet, but that's exactly what we're doing here. We're taking that zip file and we're writing it to that zip folder. Then we go into the folder. We unzip that file, and we're going to rename client32.exe, which we just saw here, to whost.exe. So client32.exe is actually the net support application. We'll get there in a second, but that's what it is by default. And then client name is what we're renaming it to, which in this case is whost.exe. So we have a couple of really fragile but still useful indicators. First of all, whost.exe inside of app data local, or app data roaming, I should say. That's weird, and you should watch for it. You should especially watch for it if you can do regular expression detections. App data roaming 12 characters exactly of alphanumeric, and then whatever that is. Okay? We have one more payload to decrypt and a new key. Let's go ahead and decrypt this new payload here. We need to change up that key, right? From base 64, XOR. Yeah, it's invalid, but I still... Hold on a second. Oh, no, this doesn't do... Day 64. Yeah. Same deal. Oh, no, no, no. Wrong key. Wrong key. There it is. Look familiar? So, right, that was this like weird, not even security measure. I don't know why that's in there. But this is a registry location. Pretty common, right? That's a persistence location. And you can see this is kind of interesting. So first, we have a new item property. Path is registry. And then we're going to create a new item property, experience host, misspelled. And that honestly, like, that's an easy detection, right? Most proper software is going to spell experience correctly. Not all of it. I've seen typos in actual software, but hey, look, if they're not going to take the time to spell check their stuff, we might as well take advantage of it. That's an easy detection. Writing to experience host with an I instead of an E. Go after it. So what is it doing? It's writing that there as an auto run, right? So that's going to run on login for the current user, right? Because we're in the Hive key current user, right? That's the registry Hive we're in. So something to note is that if you're just getting started in this, you might be wondering, like, well, why are we not elevating the system? Where's the privilege escalation? They don't usually care, honestly. These guys don't care. They're not after that. They don't have to. There's plenty in the user folder that they don't really need to go after anything crazy. Plus, there's no guarantee that that the user's an admin. To go even to become admin on the system, to say nothing of going to the system level. But yeah, they don't need to at SocGholish access brokers. That's a good way to put it. There is something cool here, though, that I think is interesting. Invoke WMI method, computer name, class 132 process name, create argument list, fpath client name. So this is where they are invoking WMI to start a thing, right? And that particular thing happens to be our... Sorry, I just completely struck out on that sentence. Let's try that again. They're using invoke WMI method to launch a process, right? In this case, it's our malware from the malware location. But there's something else kind of interesting about this. Which is that if you try to do this as a regular old user, it ain't gonna work. Right? If you look up invoke WMI method, it will tell you. I don't know why there's nothing I can do about it. Actually, there might be something I can do about this. This is a problem I'm having with Vivaldi. Oh, I see. I made 2 mistakes, not 1. And it didn't help anyway. Okay. I don't know why, but Vivaldi does not honor light mode, dark mode options for certain sites in Linux. On Windows, it works fine, but on Linux, it just doesn't. So certain sites are like light mode. However, there are 2 things if you run into this problem. If you're using Vivaldi, there are 2 fixes. Fix 1 is, did you know that Vivaldi actually has some kind of random filters you can add to pages? Watch this. Transform 3D. It's unhelpful, but you can do it. But also, you can filter invert. It's not perfect, but it'll work for quick dark mode if you want to. The other way to fix it, and this is more radical, is if you go to Chrome flags, or Vivaldi flags, right? There's this flag. I don't know if anyone's played with this. Auto dark mode for web contents. You can enable this. You'll have to restart your browser. And everything will be in dark mode. It doesn't always work super reasonably, which is why I keep it off. But it's kind of fun to play with. And so this is like, it's in there. You can turn this on, and every single site will attempt to render in dark mode. I don't want to do it right now, but if you're using Vivaldi and you have that particular annoyance, that's how I fixed it. Okay, but the point, getting back to the actual thing we're talking about, yeah, invoke WMI method is part of management. Right? You don't get this, usually. Look at the other stuff that's in there. Some of them you do, I guess. But, like, this just does not work. And even if I were to run PowerShell as an admin, why does that matter? The reason it matters for this is that I think it's interesting that they're taking the time to do an invoke WMI method here to launch this thing right away, not knowing whether it's going to succeed or not. Unless I'm doing something really dumb with invoke WMI method and like it should work out of the box and it just won't for whatever reason for me. You seem to be able to run invoke WMI method over here. Interesting. Well, that's worth a search. Can't run invoke WMI method. Or let's call it not recognized. Yeah, that. Oh, is it a PowerShell 7 thing? That's why. Check this out. Works. That's really funny. It's a PS7 thing. So in PowerShell 1 and 2, it works fine, right? But in PowerShell 7, which is what I use, it doesn't work because in PowerShell 7, you're supposed to use sim commandlets. So this actually will start this up right away, as long as your PowerShell interpreter is set to PowerShell 1 or 2, not, or what, 5, but not 7, which is what I use across all of my tools. I wish Duct Tape were here; he'd make fun of me for this. It's his fault I have PowerShell 7 everywhere anyway. So that's interesting. So there you go. A quick defense against this is to move to PowerShell 7 for everything. I'm sure that won't break anything else. Did someone say something about a standalone PowerShell 7 binary? PowerShell 7 is standalone. Look. Well, standalone sort of. You still need to bring the DLLs with it. But if I go to PowerShell? Yeah, PowerShell 7. I mean, honestly, it's stuff that you'll probably have if you have the .NET framework installed, right? All this stuff is probably there somewhere. But, right? So what you're looking at is it's a .NET project that's packaged as standalone. Not single file, but as a standalone, right? So all the DLLs it needs are installed there as well. What am I looking for? I'm looking for Push. There it is. Yeah. So push.exe, like, you can just copy this whole folder to another computer and it'll just work. As a matter of fact, what did I do? I did that to mess with Teams. This is a fun trick, Red Teamers, if you want to do this. So Teams has this update method, right? Squirrel.exe. And what it does is it runs a predefined updater binary inside of the Teams directory in AppData But you can have it run and set up startup programs. You can have it run other stuff, provided two things. One, it is in the resource folder that Teams uses inside of AppData That's requirement 1. Requirement 2, it's signed by Microsoft. Well, guess what's signed by Microsoft? So if you drop this entire folder into Teams resource directory, you can make Teams automatically launch your PowerShell interpreter, and you can pass arguments to it, so you can have it run a script. Does SocGholish downgrade a user's PowerShell version? I don't think so, but the trick is that if you run PowerShell.exe, it will just use the PowerShell 2 or PowerShell 1 version, right? And that's usually what you'll see happen. I mean, on my host system, right? If I run, sorry, let me bring this over here. If I run PowerShell, what fires up is old school PowerShell. And that's usually how that goes, right? Because you're not overwriting that particular path. PowerShell.exe is still at, the original path. PowerShell 7 is actually located someplace else. That's where we were just looking. Okay. So, oh my god, no. Magic Boy, just FYI, your Blue Jupiter repo got a shout out on its detection engineering blog? Oh god. That's so embarrassing. It's not in good shape. It needs so much work. Also, I can't see it because I have to sign in. That's cool, though. Thank you. Basically, could you pop a reverse shell in the PowerShell profile in the PS Home dir and have that run on launch? Pop a reverse shell in the PowerShell profile in the PS Home dir and have that run on launch. The answer is yes. You could absolutely do that. This thing? Yeah, you absolutely could drop something evil in there. Yeah. I mean, look how cool my PowerShell is. This file is how I've done that, right? There's a lot of stuff in there that is launched, that is happening before I fire a PowerShell. Watch. I'll close this and reopen my PowerShell 7. And it'll tell me, right? It did the profile load, took 752 milliseconds. So, yes, absolutely. If somebody is using a profile, then you can mess with it. But here's the thing. Going after a user's PowerShell is pretty rarefied. That's kind of like... That's the kind of nightmare scenario that we cook up for backdoors and breaches where, you know, there's an attacker who's going after developers, which is admittedly really scary. Kind of a different situation than what SocGholish is doing, because most of their users will not have PowerShell profiles or know what PowerShell is. Conversely, this is an argument, I think. Yeah, you could do that. And I think that's kind of an interesting trick. It's one of those things where it's like, I don't know if smaller files are always better. You could dump that whole thing in there. But no. I think that all of this malware, anything that uses PowerShell like this, is an argument to say, who really needs PowerShell? Who really needs to be able to execute PowerShell.exe as their user? Right? Now, there are some weirdnesses, right? Because technically SCCM definitely does need it. They have, what is it, the network access account or whatever, which comes with its own troubles. SCCM is a complication for this if you use that for config management. But generally, that edge case aside, and you could limit that to like a different process, right? But other than that, pretty much nothing at the user level for most folks needs PowerShell. There are, of course, exceptions to that rule, but it's worth exploring, like, who really needs it in your org, right? And how many attacks could you prevent from stopping A, that, and B, maybe shutting down JScript as a console script host availability. I don't really know how to do that second one, but I think that you should do it, because if it's possible. I actually do think, hang on a second. My bad. There is a way to do that. Yeah. This is old school stuff. Oh, maybe ASR? I swear there was a way to prevent JScript execution. I'll look into it. All right. Let's move on. We have fully decoded the scripty parts of this, and now we're down into this executable that gets dropped. So what do we have? Associate to Notepad. That's not the worst. The problem is that... Hold on, do I still have my evil JScript? I do. Okay, cool. Yeah, opens with. If you change it, I think that's right. Change the file association from script-based host to Notepad. That's actually a thing you should just do, by the way. Yeah. For JSE, absolutely. I don't think there are any Windows components that use JScript that way, and if they do, I think they're invoked directly with WScript. I don't think that anybody is, like, through Explorer doing that. So That would be a super good hardening recommendation. I'm gonna try to do that tomorrow. Right, so we have this client32.exe, and let's just real quick do the usual stuff that we would do. Oh, did I not? Fine. I thought that I had added that. Let me do it right now while I'm thinking about it. So what I'm going to do is I'm going to take this and add it as a custom search engine in Vivaldi. Search. Where's my plus button? Add. Virus total. VT. And then it's GUI search, I think. And then whatever we're searching. So it's an S. I think that's good. Let's just confirm that works. It did, but I searched the wrong thing. Let me try that again without the whole URL. Awesome. So we have 11 detections. Riskware, remote admin. Let's look at some details. It's signed, and this is again where it kind of... This is the net support remote control thing. So here's the thing about net support. It's a legitimate piece of software, which is why it's nice for this use case. The trick is how it's configured. How is it configured? With some INI files. This one is just about icons and stuff. Client32.ini. Here we go. Don't know what this is. Maybe it's a key of some sort. But as we move down, this is the file name, even though that's not where it's getting installed at all. But look at this. We have more juicy stuff. We have two things. We have a gateway address and a secondary gateway, and then a shared key here. Which is what I assume GSK is. So if we go to this, like, it's 443, we can visit this in a browser. Yeah, that's dead. But what about this one? And it may be looking for other URL parameters. Who knows? We'd have to do some Wiresharking to see. But now we have a couple more indicators, right, that you can pull off of that. That they're going to use these gateways, and this is kind of what you're going to connect to when this thing fires up. Other things to note, we have some DLLs. We have remote command stub.exe. We have some other DLLs, which we can take a look at. We also have this inf file. Nothing particularly wild in here. And again, I think this is all legitimate software. It's just about where it goes. All right. You want to try some dynamic analysis? We've got time. I was having a problem with Proxmox, and I want to fix it. Enable the just simple aux percent. Okay. I've been having problems with snapshots, and I want to get this sorted. Okay. Thin boom. Sorry, I'm 6. All right, thin pool auto extend threshold should be at 70. So we'll change that up. Stupid VI. You know, no, I'm not living like this. Great. Yeah, that didn't work. So we change this to 70. And that's at 20. Good. It's weird, though, because my thin pool looks fine. Right? But for whatever reason, snapshotting is not working out the way that I want. So, yeah, this didn't work. And that relocked the machine. What I'm trying to do is just take a snapshot of the elk stack. Without the RAM. Oh. Sucks. Snapshot already started. All right, well, I guess we're just going to live with it for now. In which case, we're good, but I got to go set up my victims. All right, 841, and they want this enrollment token. So I had this thing on Sunday where this is a little sysadmin-y. Sorry. I had this thing on Sunday where I took the whole day and I studied start to finish the Salt project documentation. If you're not familiar with Salt, it's another configuration management platform. And the reason I did it twofold. One, I was curious whether Salt would be a better choice than Ansible for a lot of what I'm doing in the lab. And the other reason is because Security Onion uses Salt, and the last time I tangled with Security Onion, it drove me crazy. It drove me crazy. And so I didn't want to not know what was going on with Salt anymore. Ugh. What? Oh, interesting. My enabled WMI tracing doesn't. Seem to be very appealing. Well, that's fine. I can turn that off. I don't think we need WMI tracing for right now. Okay, so that'll take a second. Don't forget that tonight also, as always, Wednesdays are sort of our unofficial AMA. So if you have any burning security questions, feel free to drop them in chat as we get our dynamic lab up and running. I really need to figure out a way to do this faster. So Ansible is installing all the stuff we need. And then it will install the agent so that it phones home to Elastic and we get data. And then we can drop malware on it. While we're waiting, let's talk about where you get malware samples if you're not lucky like me to just catch them in the wild as part of your job. If you want to analyze malware, I have a couple of sources that I really like. If Husky's around, I'd love to hear about Husky's favorites, or HGB's, or anybody else's who's in the biz of defense. But I'll talk about some of mine. So probably my absolute favorite is Recorded Futures Triage. Here's why. I get not only to see what it did on their sandbox, but I get their PCAP, and I get the sample to replay it myself. So it's not necessarily new data, but I get to play with it and understand it slightly differently. VX Underground. So, okay, let's talk about VX Underground. I like VX Underground too. But VX Underground doesn't always have the latest and greatest. Right? If you go to their malware collections and drop down, like, it does have some great stuff. I have a few other places that I've found that work great. So triage, let's see how you would search for it in triage. So in triage, if you go to reports, you can search by family. It doesn't tell you this anywhere, but you can search by family. So if we do family SocGholish. No. What about fake updates? Nothing. That's annoying. But you can kind of see how these are coming in here, right? All public samples. There we go. Malware Bazaar. So Malware Bazaar, that's the other one that most folks go to. Part of the abuse.ch family. Right? There's also really cool stuff at URL House, ThreatFox, and Yarify. But Malware Bazaar has some great stuff. So if we go to the database, yes, I'm not a robot. That I know of. I could be a Nexus model. It would explain some things. So let's see. We would do tag SocGholish. Zeltzer is a great one. Yeah. Okay, so in Malware Bazaar, we have some nice samples here. And we have some nice JS samples. We might take one of these and compare to see how similar they are. All right, this one was from just the 23rd. So we'll take a look at this maybe and do a comparative view here. Oh, and it's from malware traffic. That way you know it's good. And that's kind of the thing. If you want to go right to the source, malware traffic analysis, right? .net. Please don't be bad. Yeah, there it is. This is the good stuff. Oh, were you on the? Oh, hey, yeah. Well. Do you want to take a look at yours? Let's take a look at yours. Why not? Download sample. Don't mind if I do. It's a JavaScript mess. Oh, yeah. Well, don't I know it? Oh, wait. I don't want it from here. I want it in Kali first. Okay. Ah! Yeah. All right, so actually, I see some stuff that we might actually be able to use JSD obfuscators for this one. Where's mine? D4JS. All right, it's not much better, but it's sort of better. At least it's formatted. The stuff that matters is at the end. John dies at the end. Okay. Out of curiosity. Yeah. That didn't really help. New ActiveX object. Yeah. Well, this is fun. This is definitely a job for dynamic analysis. I don't want to deal with this. Ugh. Gross. Well, another thing we can do. Let's see. So this creates a new ActiveX object. And then it plus A0, whatever this is. So you know what we could do? Is run this in Node. And just like see what happens. Invalid or unexpected token at 1735. Oh, yeah. Look at that. I think there were some mistakes in the deobfuscation. Looks clean now. It went from red to white. Yo! So, what do we get? We get MSXML2 XML HTTP. And it is just a string. Right? I mean, if it's string concatenation, let's confirm that. Let's see. Yep. Okay. So we know that this is MSXML HTTP. This is the string XML HTTP. Okay. What else shall we do? I'm going to take basically any of these invocations. And I have to say, I think I'm not really like a malware analysis guy, but I feel like I'm getting slowly better at it. Yeah, I'll put this in the chat for anybody who wants to play. But one of the things that I think that I'm learning that I prefer static analysis to dynamic analysis, mostly because of my programming background. Let's see if we have an agent. We do. And sysmod should be coming up shortly, so we will have data coming in. Again, this is going on your playbook docket. Good. So this is... All right. There are only 16 people or so here, so whatever. I can just say whatever I want. What Husky's doing, right, is taking actual threats and using that for his threat emulation, which is his job. Not coming up with, like, the most weird, cool, red teamy thing you could possibly do to dunk on blue teams. That's not helpful, right? So I was having this thought today as I was, once again, going crazy learning Kerberos stuff, which is a real sticking point for me. But I have a question. How often do organizations actually get popped with something like constrained delegation? Right? Where, like, they did everything right except there was a service account that you could get after with resource-based constraint delegation. Or how often is it that it's that the thing that they did wrong was ADCS? And the reason I was thinking about that was because, pardon my leap of logic here, the reason I was thinking about that was there was a member of our Discord who had an injury from boxing. And boxing is... It's not simple, but the techniques are finite. Like there are a certain number of techniques that are allowed in the game, the sport of boxing, right? Jab, cross, hook, shovel hook, uppercut, overhand. Like, they're learnable, right? And just bear with me for a second. What I was doing was I was actually teaching a recovery technique from Wing Chun. Wing Chun is a completely different animal from boxing, right? It's so much more formalized. The techniques that are inside of Wing Chun are none of them are basic. Even the straight punch of Wing Chun is a different kind of technique that requires all of this understanding of your musculature. And what I'm getting at is boxing works, right? It works right away. Whereas it takes years and years and years to master the techniques in things like Wing Chun or other traditional martial arts for them to be effective in combat. And therefore, you never see them. And I guess that's kind of my point, which is that when you're in this offense-defense conversation about InfoSec, it's important to understand the advanced techniques. It absolutely is. But it is also very possible to get too hung up on them and worry too much about the conversation around, like, the most elaborate Windows compromise or the latest privilege escalation that is extremely difficult to pull off, right? A 0-day that is theoretical but doesn't have a proof of concept yet. Because yes, you absolutely can learn how to use Bong Sao and come over and, like, do eye strikes and all that stuff. You can learn how to do that. But sometimes, you know what? You just gotta, like, cover up. And knowing that bigger thing is probably going to help you defend better in an organization. Right? I guess stick to the fundamentals is what I'm trying to say in the most convoluted way possible. All right. We're ready for dynamic analysis when we're at that point. Let's see if we can finish up our... I am super curious about this, though. Oh, this is a big one. I'm told it's not uncommon in Charlotte versus Sales mixed figures, so those are in the attack chain. Uh, 3D3. That's all balanced. Good. So after all of that, oh. Wow, did that work well? Okay. What are we sending? Probably just a key. CoinAngel.online. Oh, hold on a second. PivX, install HTTPX. It's too cool not to use. We're going to use HTTPX. It's better curl. And I put it in my list of stuff.
Leaving behind only buildings, bridges, machines. If you should awake to such a world tomorrow morning, what would you do? Where would you go?
Come on. Name or service not known. Oh, because it's got to be post. Any chance someone ran it on any run that we can recover? Well, we're gonna get the second stage ourselves. Yes, that's what triage is for. Oh, yeah. But it didn't do anything. Nerds. Open, post, Ajax timeout, send. Oh, you know what? Let's send this as the data, assuming this is the data. Content. Data. Form data. Content. Yeah, I suspect it's not.
47 synthwave with all your favorite artists.
What's up? This is Miami Nights 1984.
This is Celerect LA Dream.
This is FM 84.
Hey everyone, this is Arcade High.
I'm Alex, aka Highway Super.
Nope.
This is Night Ride FM.
That's unfortunate. All right. Well, let's try our first our SVG, because we know we have that, right? Let's fire this off and see what happens. So we'll head over here, and we will SSH to our victim. PowerShell. Okay, CD downloads. Get right. F23.ps1. Actually, you know what? Use basic parsing. Just fire it off. Let's go. Incredible. That's so funny that if you do it this way, look, it returns all his data. That rules. Thank you very much. Look at that. There's whost. Let's go see what Elastic saw. Hopefully something. On my company, I think they realized some anomaly scanner software is some evident dangerous things for our daily work, and no one wants to ever. The InfoSec department is quite big. Okay. Yeah, it happens. Oh, look at this. Very rich. Very rich information. Very cool. Let's focus down. Right, let's go get event.code. Let's go get is one of one. All right, let's change up what we're looking at here. Yeah, we'll do file.path for the 11s. sc.exe, so those are services. Perhaps not that surprising. Oh, so look, here's all this whost. Look at this, right? Whost is doing all sorts of cool stuff here. If we look at these, we'll see the DNS. So there's the gkdkr.icu, right? So here's a network connection, right, to 62, 172, 138.67 over 80. Uh, enable packet capture or specify an event provider. What am I missing here to enable it? Oh, start capture. Doofus. There we go. So we're capturing everything that's going out on 80, because I want to see... They're plainly using HTTP. I don't know why, but they are. So I want to see what that's all about. We also saw some 443, but we're not going to be able to read that anyway. And are we seeing anything since then? Not really. We're definitely seeing... Oh, this is cool. We saw Geo netsupportsoftware.com, right? That would be something we'd expect. There's your PowerShell. Why don't we add 4104? Good old 4104 for PowerShell script block logging. Oh, yeah. Look at that. Definitely got some good stuff in there. You know, when this lab setup works, it works. Ah, that looks familiar, right? Exactly what we saw in the dynamic or the static analysis. And look at this chunk of 4104s. The reason why you're seeing a bajillion of these is because PowerShell script block logs have a set max length. And so when we have, yeah, look at this. When we have a massive payload like the one we saw, the script block logs get chunked. In this case, that single massive script that was our first big payload resulted in 279 separate Windows event entries. This is a problem for your SIM, right? It's a problem for us, but think about when that happens at scale. And by the way, SCCM does this too. If you're ingesting PowerShell script block logs, when you do this with massive scripts, you're producing hundreds of logs a second, like hundreds of times more logs than you were previously. So you're going to see this EPS spike. That's a huge pain. All right, what I'm going to do, I'm going to fire this off again. Oh, look, it changed my directory. That's so funny. Did you know you could do that in PowerShell? you can use CD with Linux syntax to get where you want to go. All right. Now that we're doing Let's do packetmon stop. Right. And then we're gonna yeah, that's fine. We'll keep that. We'll start it again with a packet capture. By the way, in case you're not aware of what I'm doing, pktmon is the built-in packet capture utility inside of Windows as of, I can't remember what build number. It's not like super new, but it's new enough that not everybody knows about it. I don't have to use Wireshark. I can just use pktmon. It's like TCP dump. And let's rerun our PowerShell thing. It'll write to a different location. Right, we'll see a different one of these. Yeah. Still works, and it'll still connect. Which is what we want to capture, right? It errored out on writing the registry key because it already existed. It creates PCAPs. Yeah. Hold on to your socks. If you don't know about pktmon, you're going to love this. All right, let's see if we got anything else cool here. And here's the thing. I like this a little bit better than just like having to set up Zeek or having to set up a span port. That's a huge pain. This is not, right? There we go. This is the new one coming in. Writing files. What files did it write? So, okay, anytime you see the PS script policy test, whenever you see one of these, and you'll see them fairly often, what does it mean? What does it mean that PS script policy test is happening? Class. Because it's there. It's in your events. And it's noise unless you know what it means. What does it mean? Testing against AppLocker. Not just AppLocker. It's testing against your execution policy. And AMSI, by the way. Yeah. It's a pre-flight, basically, for the script. So that's why it's at temp. And if anything about the script doesn't pass muster, doesn't run. All right. And then this was what? Process whest.exe. Okay, so this is the new one firing up, and then I should see some network connections. It looks like it did love the fact that we had a current version run already there for experience host. So let's try this one more time. Software, Microsoft, Windows, current version. Run. Property. Experience host. I can't spell property, apparently. Is it just name? Yes, it is. Okay, so the reason I did that is because this time I want it to run and not freak out. So we're gonna have like 3 versions of this thing on here, but we're gonna blow it away anyway, so it doesn't matter. There we go. Some new action here. Okay, I refuse to believe. What is this MS Cores doing? Oh, that's got to be calling out to some of the other stuff that we're doing, right? In the script. We're seeing a bunch of stuff come in now. There's your management, right? So oh, a ton of file rights. Very good, very good. I think that's legitimate. Okay, then we're back at the PKTmon. I think we're good here. So let's go ahead and PKTmon stop. Okay, and then check this out. So it saves at this ETL file, but look at this. PKTmon ETL to PCAP. Oop. Went too far. And now we have ourselves a PCAP NG that we can just grab. Remote into the machine. I'm pretty sure that I installed Wireshark on this tool specifically for this purpose. I didn't? Well, whatever. Let's just look at it. All right, so now we have it. Let's go to samples. I can put it kind of anywhere. It's fine. Let's just take a look at it here. Yeah, I know new version of Wireshark is... I don't care. All right, let's see what we got. They've got a lot of out of orders. That's interesting. Ooh, packet size limited during capture. Awesome. There it is. There's your there's our first. That's the W get. Okay? And that's all we got because it was so big. Nerds. It's still loading everything. Okay. Gonna let this sort itself out. Meanwhile, let's head back over to our HGB's sample. So what did we find out about this? We saw that it was calling out to something, and then we don't know what happened after that. But we now have a method of deobfuscating this bottom component of these. So I'm wondering if maybe that newer sample is a little bit more accessible. You know? So let's see. That was wrong. Tag. SocGholish. There we go. Yeah, this is a few days newer. There's no guarantee. We'll try it out. All right, we'll close this one up. Close all these up. We don't need these up. And let's go to... All right, let's download the sample. Update.js indeed. And we go back. Yeah. Patching Triage has a report on it. So what should we expect to see here? Okay, so here we see update.js. It calls out to DCE42 shrubs.emptyisland.pix. It posts data, which you might want to check out. Subscribe event. So was that it? I think that appears to be everything that it thought was evil. Well, that's unrevealing. All right, let's see. Is this sorted out? We have more than one TCP stream now, finally. Oh, Lord. All right, let's clean this thing up. So, we'll do a live remediation. Get process. A little WMI going on here. But also, what was it? whost, right? Yeah, there it is. So instead of going after process IDs, what I'll do is get process where process name EQ whost stop process. Goodbye, whost. And now we'll also remove that registry extension, or that registry value. Oh, cool. So, okay, it's still there, so we're gonna remove item property. Or is it name? Yeah, name. Experience host. All right, registry's clean. Blow these away. Light is green, trap is clean. Ghost is safely incarcerated in our custom-made storage facility. Which means we can, when we're ready to, we can run some new malware here. Okay, so there's only this data. The PCAP was not super helpful. And you can expand how large you can make those buffers, which might be useful for our next run. To always log the entire packet, set this to 0. Default is 128 bytes, so we should do that next time. PKT size to 0 to capture the whole thing. That way we'll get the whole story. Right. This is the intel I linked to malware traffic's upload. Okay. I want to see what we can see. Oh, dang. I don't put Wireshark on here. Well, I will now. Assuming I can. Kako. Install Wireshark. Oh, yeah. Okay. Well, that'll be added to the analysis box. For next time. Okay. We were grabbing this thing. Okay, unzip mwt.zip. All right. What kind of nonsensory info for this sample? Oh, it's so much nastier. But shorter. Ugh. Oh, actually, you know what? It's not that bad. It's minified, but it's not, All right, we have some junk up here. Let's try to clean that up a bit. Much better. Ooh, and we have trouble right here in River City. Oh, it's doing the same thing. There were just a couple of these lines that it... All right, everything else looks good here. I think they use a homebrew variation of obfuscate.io. Okay. So saying not function. So this returns a bool. Function WAN object. Totally insane. It's like they're re-implementing a subset of JavaScript. Yeah, that is exactly what's happening here. They're re-implementing at least a subset of JavaScript with their own variables so that they have access to the entire language by way of variables and other functions. Well, gross. But, I mean, at the end of the day, what are we doing here? Return ZR dot equals ZR. ZR. Well, obviously we're going to have to console.log ZR. And return nothing. Ha! Good God. So this is the entirety of what they are producing. It's an ad hoc, yeah, it's an ad hoc language. It's like a DSL. I think is a good way to think about it. Okay, so then where are we here? Object size function rt equals n or function return nt. From a console.log n here and nothing. This is weird. I'm looking for a hook in here. Something that we can start pulling at for a static analysis. Return ZR equals... Var ZR equals, okay. Itself and then ZR. Okay. Not function. All right, let's return that, actually. Huh, that was weird. Oh, maybe I wasn't logging in the right place. No? So if object equals type of exports and undefined is type of module, then module.exports equals R, else function equals type of define, and fine. Okay. Else. Oh, I see what's going on. It's a bananas tertiary. It's like a nested tertiary here. Okay, so underscore. It's underscore JS. I don't know why it took me so long to see that. It's underscore JS. It is indeed a subset of the language. Underscore is cool. I haven't used it in a long time. So this is very similar to what we were looking at before with Bootloader. Are we sure? Like, maybe I wasn't looking at Bootloader. Maybe its attribution was not correct. Yeah, so underscore.js. Come on. Underscore .js. Check this out. Look familiar? Okay, so the interesting stuff isn't at the bottom. This is very similar to what we were seeing before with the chroma.js, with the bootloader. There is going to be stuff that is embedded in here. So now that we know that that's true, right? Now, unfortunately, we can't pull the diff the same way. Well, maybe we can, if they use the minified version. And assuming it's the same 113.6. Okay, so it's the latest version. So let's try underscore min.js. NR. Yeah. We could just, like, it got rid of the comments, but I think we can do this. Okay. So what we'll do is... let's actually, you know what? Let's run it through the JavaScript deobfuscator. The same way. Okay. Now, this is underscore. Okay. And it has the same goofy mistake here, which we will fix. Okay. Now I'm curious if I can just, like, see functions that are weird. Because they jumped out at me in Chroma after looking at it for a second. Yeah, thanks for hanging out, HTB. And thank you for this this thing to investigate. What is the diff? All right, let's clean this up. Let's go get diff.js. So what are the differences? Very few. Very few. 45, 5A7, 10. What was the first file? Yeah, underscore. Let me get rid of the console.logs. I'm unconvinced this is malicious. Oh, I forgot to add the return back. I don't know why I keep closing the diff. It would update. So there are a few empty lines because there were comments, right? And then (1118, 1119). Then comes mix in YR, default YR. But then mix in here, default TN. So the only difference was that friends, I'm going to call it on this one. This is not a malicious sample. This is underscore. I don't know why it was flagged. Like, what are we looking at here? It's update.js. Let me download this sample because maybe this is a different thing. Every time. Okay, let's take a look at update.js. Yeah, where did all this go? This is what we were looking at before, right? Let me get to underscore. Oh, that's how. We deobfuscated it and it got to underscore. But oh my god, you know what I think happened? I think D4JS removed commented stuff. Because there's plainly stuff here, right? Oh yeah. This is the malware. and D4JS removed it, it's right up at the top. And then down at the bottom. Oh, fascinating. Okay, so now we're getting somewhere. That right there. Part 1, anyway. All right, let's toss this to D4JS and see what it does for us. Much better. Okay, now we're cooking with gas. And this looks pretty familiar, right? We have this A0, 0x56, E24B. This looks really close to what we saw before. And then let's... we had kind of two parts of this. Oh, this is return ZR. No, this is the end of the underscore. So I think we actually have found all of the evil. Consequently, what we will do is we will console.log some stuff here. What are we're doing? We're doing that, and all of this. Whatever this is. We're almost there. This looks very similar. Okay. Just comment that out. We'll just get rid of this JScript thing. Now what's your problem? There we go. Unbalanced parens. Now, if we node... There's an ActiveX object hanging out that I forgot to comment out. Oh, yeah. Look at that. And we have some more stuff to console.log up here, too. Feel terrible that HTTP had to drop before I sorted this out, but that's why we record these. Now I have to say, I'm kind of coming around on spending my time doing this, because I've been able, for this particular malware family, to pull a lot of really good detections off of taking the time to reverse these. That's not always true. Sometimes detections will get you, or like behavioral dynamic stuff will get you pretty far. But in this particular case, it has been, I think, just one. Okay. Rewarding to do. Okay. I'm going to take all these and bring them down to the bottom here. Put them on top of our other console.logs. All right. All right. So we're seeing eval response text. That's so cool. So we see what it's doing. It's going and grabbing the second stage and then it's evaluating it. Can we get it is the question. Because this one's newer, right? Yeah. This is going to get muted on Twitch. Starcadian always gets muted. I don't care. It's too good. And let's use this key. Well, we hit it. Well, the server's up. What do you think? Maybe it's the user agent? Show me everything. God, I love HTTPX. What is the Windows script host? User agent. Unhelpful. Nobody knows off the top of their head, do they? Oh, freaking Microsoft. They do this thing that messes with the back button. Boy, that's not helpful. No. I suppose I could just, like, make a Windows script host request. I even have... Hang on. I'm in Cali, right? For shame. I didn't have my user agent installed. My user agent switcher installed. Okay, you. Others. It says bot, but I don't want a bot. I want, like... Better. No. This is unhelpful. So we see that it does make the request. Well, Time for dynamic analysis, I guess. Let's see what this one has to show for us. We'll go get update. We'll put it on our victim. Go away. And then we'll see what happens next. Ah. Defender caught it. So we'll turn Defender off. Good old whack attack. All right. In theory, that's running. Oh, yeah. There's our shrubs.emptyisland.pix. And then we're going to have network connections that go out to that thing. 0 SSL OSCP. Get in certificate stuff. What happens next? Maybe nothing. Maybe this is already a dead... like a goofball, I forgot to start capture PKT size 0. Let me actually capture everything. I'm going to run it again. Because I want that packet capture. I want it very badly. And now what? Okay, so we're seeing it happen again. There's our network connection. Which, by the way... on 443, yeah, so this is properly using TLS, so we're not going to see as much out of it, right? It's encrypted the way it should be. Not much else is happening here. go ahead and run pktmon stop. See if we can see anything at all. Okay. And now we have Wireshark on the system. We don't have to mess with anything else. Seriously? No DNS. Nope, some DNS. Nothing interesting though. That's interesting that it didn't pick it up. Oh, I know why. I think it was because I wasn't running it the first time and then it was cached. That was dumb. So did you see anything outbound? You did. Well, that's unhelpful. Can I see the TCP stream? Again, it's not going to show us much, but you can see there's shrub.empty island pics in the cert. There's some negotiation here. No, we don't want to do that. Okay. I think we're ready to call it a night here. But hey, so some things that we learned. We discovered the nature of how SocGholish is obfuscating its stuff. It's obviously loading things into existing JavaScript, very similar to what we saw with Bootloader. We're seeing a request out to a first stage. It's attempting to listen. It's listening for a very short time, and then it will download a second stage, which we had when we started the stream, which was some really interesting PowerShell. That PowerShell, what did it do? Oh, right. It downloaded net support, right? It downloaded the net support remote access tool with a special configuration that will phone home to its remote servers. So to start up a remote session. So a lot going on, but also some opportunities for detections, things that you might want to look for. So we saw in our initial where did we go? Yeah, so we saw there were a couple of obvious ones. So first of all, any write to the registry with this misspelled experience host, that's one that I saw that you're definitely going to want to look for. Another one that you're going to want to look for is anything getting saved to appdata/roaming with a 12-character alphanumeric, no spaces, nothing, name, because that appears to be where these things are living. And I've seen this across a couple of samples. So worth checking that out as well. And also, there is one, this is kind of crazy, but for the net support variant of this, guess what? The client 32.exe, because it is a static file that is configured with external INI files, that hash is actually a pretty good detection, because they'll probably reuse that specific executable with different configurations in the INI. So what you can do, you can take that, be in the right place. You can take that hash and just go for it, right? You can add that to your detections. It's atomic, it'll change, certainly, but it is a good starting point. You can see it's starting to get detected. And you can see, when was our first scene? September 9th, 2022. So it's still around, and it's still getting used. The last analysis was today. So this is a good one. 11 out of 71 could be better. All right, I think that's going to do it for tonight then, friends. Thank you so much for hanging out. I hope you had a great time and learned something. I know that I did. No folks that I know on the hack list are streaming right now, but let's give Hack Smarter a raid, see how that goes. And as always, check out the hack list for all sorts of additional InfoSec streaming. I'll be back on Saturday doing some more, I think, red teamy stuff. Until next time then, thank you very much. Be good to yourselves, be good to each other, and happy hacking. I'll see you next time.